Okay, so the last subtopic of this biomechanics unit, in specifically the kinematics, we're looking at motion, but now at principles of equilibrium. So, as you can see there, we have static and dynamic, and we also have stability and balance, factors that are affecting stability. We're going to go into all of these. So there's all the key terms that if you're not familiar with right now, you will be by the end of this video. And these are some of the key skills that you'll be asked to be able to explain. So what is equilibrium? An object is said to be in equilibrium when there are no unbalanced forces or torques acting on it. Now, torques, remember, is angular rotation, a force that causes angular rotation. So if my arm is out and I'm on rollerblades and someone hits my arm and that causes me to spin, then that is a torque. That is the force acting on it. It's not hugely important in the current study design, but it's just good to be aware that a torque is a force that results in rotation of an object. Okay, and unbalanced and balanced forces, if you're unsure of that, I explained that in the Newton's 3 laws videos, so I urge you to go back over those. So we have two different states of equilibrium. We have static equilibrium and dynamic equilibrium. So you might have heard of static and dynamic stretching. Okay, it's a similar concept here. Static stretching is when you're stretching not while moving, so whilst stationary, hence the static. And dynamic stretching is when you are moving while stretching. So similar here, static equilibrium, a body or an object that is in equilibrium that is not moving or rotating. Okay, they are stationary. Dynamic, when a body or object is moving with a constant velocity. We'll get to that in a second. So there's no change in speed or direction. So they are moving. So you can see this gymnast is in equilibrium because all the forces acting on her are equal. You can see they have the gravitational force by the earth on the gymnast pulling her down, and the contact force by the beam on the gymnast. Okay, so her weight is what's pulling her down, and the contact force is equal to that. So they are zero. Those forces are balanced. Okay, likewise, her horizontal forces are also balanced. Okay, so the sum of all of her vertical forces are zero. They are balanced. The sum of the horizontal forces are zero. There's not one that's bigger than the other. Okay, so the sum of all of her torques, zero. So therefore, she's in static equilibrium. Okay, you can see another example here with a gymnast hanging from the rings. The forces that are acting upwards would be the gymnast's left and right arms, which are holding them in place. And that is 350 newtons per arm, where the weight of the gymnast and gravity affecting that is 700 newtons downwards. So you can see those two added together versus the gravity and weight pulling them down are equal. So the sum of all vertical forces are zero, sum of all horizontal forces are zero, and sum of all torques are zero. So here are some examples of dynamic equilibrium. We have a skater with a steady velocity. So that skater cannot be rotating around, because if they're rotating, then they are not in equilibrium. Okay, that doesn't mean they're not balanced. It's highly skilled still, but equilibrium refers to everything being balanced and equal to zero, all of their forces acting on them. So you can see that everything is moving in a constant speed and there's no change in direction or speed. Same with the skydiver. They're falling, they're traveling very fast, but everything is moving at a constant speed in the same direction at the same time. So balance, when we refer to balance, not in terms of balance and unbalanced forces, but in terms of someone's ability to be balanced, to control their equilibrium is what we're talking about. To be able to keep that equilibrium where all the forces acting on them are zero, so therefore they can stay in the one place. Okay, so this gymnast here, the vertical forces of both legs equally placed mean that they are zero, and her arms and the reactional force from the beam on her arms is also zero. So she is in equilibrium, but it takes a great deal of musculoskeletal strength in her arms and her shoulders and her core, but also flexibility from her legs in order to keep that position, in order to control that position. I can guarantee you right now, I would not be able to control that position. And looking at this ballerina, whilst at first you might not think too much of the degree of difficulty, but when you look at it, she's on the very tips of her toes. That again takes a great deal of musculoskeletal strength in her leg and feet muscles, and also flexibility. You can see the flexibility of the ankle there, and the rest of the body in order to be able to keep that balance. Okay, so when we're talking about balance, it's the ability to control that equilibrium, and it requires musculoskeletal strength and flexibility. Okay, so looking at the difference between stability and balance, we haven't spoken about stability yet. All right, so I'm just going to start with balance, the ability to control equilibrium, and it requires musculoskeletal strength and flexibility. So to have good balance, you need to have definitely one of those things, most likely both. Okay, whereas stability is the resistance to disruption of equilibrium. The greater the stability of an object, the harder it is to unbalance. So we're going to get into that. What better place to start than sumo wrestlers? Okay, if I was to try and push one of these sumo wrestlers over, he would be very stable and therefore very hard to move. It would require a great amount of force. Something that is more has a higher stability will require more force to move it. Okay, so it is the resistance to the disruption. If something is very light, then it's easier to move. It is less stable. Okay, there's a few factors that play into that. But the greater the stability of an object, the harder it is to unbalance. So, factors affecting stability, we have a few: a base of support, center of gravity, the body mass, and the friction between the contact surfaces. So, the base of support is basically the points of contact which are touching the ground. Okay, so the area bound by the outside edges of the body parts in contact with the supporting surface. Okay, so you can see the difference in the examples. Firstly, the greater the base of support, the greater the stability. So if my feet are wide apart, like they are in this first example here, okay, I have good stability, particularly if someone wanted to push me sideways because my feet are further apart. Okay, so I'm talking about when comparing it to here. If someone wanted to push me sideways, my feet have a wide base of support and therefore I would be harder to move. Okay, especially when you compare it to someone who's standing on one foot on their tippy toe, their base of support is tiny. So their stability would be much less. It would take lots less resistance, much less resistance, in order to enable them to lose their stability. So this standing with one foot in front of the other, that base of support might be similar when it comes to this person with in terms of horizontal, if I was pushed from the side. But this one would be much more beneficial if I was pushed from the front, because my base of support forwards and backwards is actually much larger than this person's, who's standing with each foot equally side by side. So the base of support, to sum this up, the greater the base of support, the greater the stability. So you can see some examples here. The baseballer has a very wide base of support that allows him to swing his trunk and his upper body around at a very fast speed and very accurately in order to hit the small baseball that is coming his way. Okay, so that wide base of support allows for all that movement to occur in a controlled manner. Okay, a small base of support, if this ballerina was attempting to hit a baseball that was coming to her whilst in that position, she would find it incredibly difficult because she has a very small base of support, therefore very low stability. So, center of gravity. Okay, it's the point around which the weight of an object is balanced. Okay, the center of gravity can be moved and changed by the position of the body. The center of gravity will rise when you raise your arms above your head. I'm going to show you a diagram explaining that in a second. The height of the center of gravity affects stability. Basically, you would have heard before that person's got a low center of gravity. Usually when that's said, it's talking about someone being balanced and having good balance. Okay, so it's actually referring to stability. Okay, where the lower the center of gravity, the greater the stability. Remember, stability being the harder it will be to move them because their center of gravity is lower. So in terms of football or rugby, they might be able to shrug tackles better if they have a lower center of gravity. Okay, and a center of gravity that's outside of the base of support will decrease someone's stability. So here's an example of someone's center of gravity. In humans, it is usually around the pelvic region. It depends on the person's body shape and their mass distribution, but you can tell just from the person movement, it slightly changes their center of gravity. Then putting their arms forward results in that center of gravity coming up slightly and also coming forward slightly. Okay, if someone raises their arms above their head, their center of gravity comes up a little bit higher. So this person will be less stable than this person because this person has a lower center of gravity. Okay, this last one here, this person might have a lower center of gravity, but they also have their center of gravity outside their line of base of support. So the base of support is their feet, and their center of gravity is hanging over the top of that or right on the edge, which makes it more difficult. But what I need you to get from this slide is the lower the center of gravity, the increased stability, and that is affected by a person's position and weight distribution. So here's a few more examples, and you can see how that changes depending on the position. I will pay a particular attention to this starting blocks person because quite often there's questions on that. You can see that their line, their base of support is their feet and their arms, but once they propel themselves forward, their center of gravity, although low, is well above their base of support, well in front of their base of support. So if you lower the center of gravity, you increase flexibility. You make it harder for you to lose your equilibrium. It will take more force in order to make you unstable. So gravity acts on a body through the center of gravity. When the line of gravity acts through the center of the base support, stability is increased. So here's talking about this line of gravity. The line of gravity is where the line or the space in between your two or your base of support. So in this case, the base of support is each hand, and their center of gravity is in between those two things. In fact, it's right in the middle of those two things. So that makes this person in quite a stable position because their center of gravity is in line with their base of support. And it's even better if that is in the center of their base of support. So because it's right in the center, they're in a very stable position. Okay, so you can see an example again here. Line of gravity directly above the base of support in the center, right, in between each feet. So that person is very stable. They're going to be hard to move. This person, center of gravity is outside the line of the base of support. And because it is outside of the line of gravity is outside of the base of support, that means this person is going to be much more unstable. So when we're talking about the line of gravity, we're talking about the center of gravity straight down to the ground. Okay? And when the line of activity is through the center, the stability is increased. Whereas if the line of gravity falls outside of the base of support, the person's equilibrium is disrupted. Okay? So there are reasons for wanting to decrease stability. So before we get to that, just have a look at what happens when a person becomes unbalanced. You can see, as I've explained already, the center of gravity is right in line with the base of support. Okay, so they are stable, they have a equilibrium. Okay, whereas this person, one of the P-bars is unfortunately snapped. Okay, and what that means is this person's base of support, because remember the base is the parts of the body which are in contact with the thing that is supporting them. So in this case, a beam, and it's gone from two parts on the left, so now only one part. So the base of support is much smaller, but more importantly, the line of gravity is outside of that base of support. So this person is going to find it incredibly difficult in order to keep themselves in equilibrium. It's going to take a huge amount of muscle and obviously repositioning of their legs in order to stay, but they are unstable because of their line of gravity being outside of the base of support. So, as I said, athletes can manipulate the size of the base of support and the position of the line of gravity in order to optimize their performance. So there are reasons for wanting to be on the edge of that line of, if not past that line of gravity. Okay, in a 100-meter sprint, people adopt body positions where there is a degree of stability, but from which they can easily shift their body to an unstable position. So someone's in the starting blocks, okay, their feet and their hands are the line of gravity, are the base of support, sorry. Okay, and you can see this person's line of gravity is right on the edge of that base. That is going to propel them forward. Okay, and if it's propelling them forward, they're going to have less stability, but one positive of that is they are going to have more agility. They're going to be able to propel themselves forward using that angular motion. Another reason why people would want to move the line of gravity to the edge of the base of support is to make themselves more stable. So bear with me here. We've got two rugby players coming towards each other. You notice that they're both crouched forward or leaning forward. Okay, why would they do that? Rugby players will move their line of gravity in the direction of an oncoming player so that when that impact does happen, there is a greater force required to move them off balance when trying to block an opponent. So I'll show you what I mean by this now. You can see the center of gravity is on the edge of their base of support. I know this person's base of support and this person's, their front foot is not touching the ground. I'm putting this as to where I think their foot would land when they did make contact. Okay, but you can see the center of gravity is right on the edge. And the reason for that being is when they make contact, okay, it's obviously going to pull them backwards. So if they can start their line of gravity at the very edge, they have all of this distance to move before they are outside of the line of gravity, outside of the base support, and therefore unstable. Okay, so if they just stayed upright, there would only be a small distance that they would have to be moved before they would be unstable because their line of gravity is outside of their base of support. So by leaning forward, they give themselves a greater distance from which they can be moved without that stability being disrupted. So you can see again here in a real life example, he's leaning forward, he's bracing for contact so that it would take a hit to move the center of gravity all the way back here in order for him to lose his stability. So he increases his stability in a few ways in this photo. He has a low center of gravity. He moves his center of gravity to the edge of the base of support, and that allows there to be a greater wiggle room or a greater distance that he can be pushed while still being in the base of support. So much like the crouch starter at a 100-meter race, a swimmer can move the line of gravity to the edge of the base of support so that his stability is reduced. Why would he want to reduce his stability? So as soon as that gun signal sounds, he's already right on the edge, and he just needs a little propulsion, and he will go forward very quickly because he's already in a bit of an unstable position. So it's about, if he started from back here, there would be a greater distance for him to move before he would be unstable, and when he's jumping, he is going to be unstable. So body mass, if we look at sumo wrestlers, which we're going to do in the next slide, the greater the mass of the body or object, the greater the force required to move it. If all other factors are equal, the body with the greater mass will have the greatest stability. So no prizes for who is going to win this one, if we're guessing this correctly. You can see, imagine these both had the exact same technique. They were going to propel at each other at the exact same acceleration. The only thing being different would be the mass, which obviously this bloke on the left has far more of. Okay, because he has larger mass, he is going to be more stable. He's going to be much more stable and therefore much more difficult to move. It's going to require more force to move him. The last thing affecting stability is friction. So if you have increased friction, you have increased stability. You're going to be harder to move. It's going to take more to move you. Increasing can improve sporting performance. So spikes, shoes in order to allow your feet to grip on a surface, whether that be cricket spikes, athletic spikes, football studs. There is a million different types, but they are all designed to increase friction and therefore increase your stability. Okay, so there's also gloves. If you want stability between the hand and the golf club in which they are holding, because they don't want the golf club to turn whilst it's in their hand, or to the angle to change slightly because there isn't enough friction. So wearing gloves will increase the friction and therefore increase the stability between the hand and the club of the performer. Another one, you can see a surfboarder putting his wax on top of his surfboard. What this does is increases the friction. Okay, so there will be more grip, which is what friction is. There's more friction between his foot and the board. Therefore, it's going to be more stable. It's going to require more force to move him off that board. Okay, there are times where you want decreased friction. So decreased friction should be a decreased stability, not increased. That's a typo there. But decreasing the friction can improve sporting performance. So here is a classic example of these nut jobs who go down face first down a bobsled run. And by having themselves on some very sharp and small base of support ice skates on the bottom of that sled, okay, it means they're going to travel incredibly fast because there's going to be not much friction between those tiny little blades and the ice, which is also smooth as well. So therefore, there is decreased friction, which means they can travel faster. They will travel without as much disruption as what they would be on grass, or what they would be if he had a flat bottom rather than a sharp bottom. So, summary of this, you can maximize your stability, which is the amount of resistance that you can take in order to stay in equilibrium. You can maximize that stability by increasing the base of support, ensuring the line of gravity is inside the base of support. You can lower your center of gravity, increase the mass if and when that is possible. Obviously, that can't occur within one game of something. You can't just increase your mass unless you were putting on a weighted vest or something of that description. Increasing friction between contact surfaces, extending the base of support towards the oncoming force, like the rugby players we showed, and shifting the line of gravity towards the oncoming force. So, here is a really good summary video, which just goes through everything regarding equilibrium. So I recommend that highly. But let's go through a few questions. The conditions required for an object to be considered in equilibrium are the correct answer. Give you a second to look. Is all of the above. So the sum of all torques is 0. The sum of all vertical forces is 0. The sum of all horizontal forces is 0. All the forces acting on them are even, equal. They are balanced forces. Therefore, they are in a state of equilibrium. Okay? Pause this video and answer this question for me. It asks you to rank the following scenarios in terms of least stable to most stable. So you should take into account all the figures and all the different factors that we just went through. Pause the video now to try and see if you can do that. Okay, so the most stable would be, I've answered this in the incorrect way. I've done it the other way around. So it said least stable 1 and most stable 4. I've done it in the opposite way. So you need to be very careful with that in exams. There's a good little practice test for you there. Because it's very easy to do, to just be rushing through something, like obviously I've done when I've answered this question. And you've done it correctly from what you thought the question was, but unfortunately you're going to get 0 marks out of 4 for something which really, if I had read it properly, would be getting 4 marks out of 4, which makes a very big difference. But if, let's just do it in the reverse order. So for me, the least stable would be the small base of support with a high center of gravity, okay? Because a higher center of gravity results in a worse stability, and a small base of support, again, means it's not going to take much in order to knock that person off that stable position. Large base of support, low center of gravity, okay, that's the complete opposite. So that's why that is the most stable position. And then 2 and 3, we have a crouching start position in sprinting and a swimmer on the blocks in starting position. I think it's quite a close line, but they both have a low center of gravity. Just within the base of support is the line of gravity in this one. the line of gravity is outside of the base of support. So because the line of gravity is outside, that means they are less stable than someone that has got the base of support, the line of gravity just within. All right, compare and contrast stability and balance. Stability and balance are concepts that are closely related. Stability is the resistance to the disruption of equilibrium, whereas balance is the ability to control equilibrium. So it's important that you're able to distinguish the difference of those two. So there's two examples: a sumo wrestler not moving when a force is applied on him, whereas a gymnast doing a handstand in equilibrium and able to keep opposing forces in balance. That requires a great deal of strength and flexibility. Okay, so keep your eye out for this one last video for this biomechanics topic. Best of luck. A slightly longer one today. Hopefully that makes these concepts a bit more manageable. Good luck.